Today's lesson is a review of the classification of matter, and then we're going to go right into a little more detail about the elements on the periodic table. So, in our last lesson, we left off with the matter flowchart. So, here's another version of the matter flowchart. And if you notice, we said in chemistry, we study matter. Chemists study matter and the changes that the matter undergoes. So we need to understand how matter can be classified. This flowchart is an excellent reminder of just how interconnected each of the types of matter are with one another. So matter can be categorized as to either a substance, known as a pure substance, or a mixture of substances. So pure substances have a definite composition and they are homogeneous. All pure substances, and I'm going to add that pure substances, they're all considered homogeneous matter, which means if you have a sample of any pure substance, all the atoms or molecules are going to be identical for that particular substance. Pure substances can be further subdivided into either a category of an element, which corresponds to each of the 118 elements on the periodic table, or compounds, which is what forms when the atoms combine chemically. Elements, like here we see a picture of some silver, a close-up of silver. Elements are the building blocks of all matter. So here is a sample of silver, which is composed of many, many silver atoms. Now, when the elements come together, they bond. They can bond through ionic bonding or covalent bonding or metallic bonding. So when elements bond, they form what we call a compound. Now, compounds can be separated, but only through a chemical process. Remember, chemical changes alter the composition of the substances. They have different chemical and physical properties when their bonds are broken into their atoms. So elements cannot be broken down chemically or physically, but compounds can be broken down chemically. So here we have a compound known as beryl. All right, over here off the right-hand side of the matter flow chart, we have mixtures. Mixtures are can have variable composition. Now, they can always be separated through physical processes. And when they're separated through physical processes, they're separated back to the substances. So again, these are interconnected. The substances will then branch off into either elements or compounds. Now, of the mixtures, there are two types of mixtures. Homogeneous mixtures, which has a uniform composition throughout. So an example of a homogeneous mixture would be like salt water. Here you have stainless steel, which is a solid solution, if you will, of metals that have been melted and then mixed together. They're the same throughout. Now, heterogeneous mixtures, the prefix hetero, means it has a variable composition. It's got a non-uniform structure in distinct phases. So here you can look at this sample of granite and you see the different color, the variation in the color here. Another example of heterogeneous would be like oil and water. You can see the oil and the water in the mixture. It's heterogeneous if it has several different phases. So it has two or more phases is a heterogeneous mixture like oil and water. And homogeneous mixture would be like salt water. If you were to have a container of salt water and just looking at it, you would not know that there was salt in there unless, of course, you tasted it. You would not see it. So it would have a completely uniform composition. So I want you to take just a moment to classify these substances based on what we've learned into either a category, is it an element? You can put E if you think it's element, C if you think it's a compound, or M if you think it's a mixture. Now, I'd like for you to pause the video and you try to do these on your own. and then resume the video and check yourself and see how you did. Now, just for purposes of the video, I'm going to continue talking about these. All right, so hopefully you've had time to answer them. So let's check and see how you did. So silver. Now, element, compound, or mixture. Hopefully you're referring to your periodic table. And if you look on your periodic table, you will find silver as an element. So I'll put E element. Hopefully you said element for that. Silver is an element. It cannot be broken down chemically or physically. A pine tree. Well, certainly you're not going to find a pine tree on the periodic table right by itself, so it's not an element. And if you think about a pine tree, it is very complex. It's not just two or more elements bonded together. Pine trees are made up of many different substances mixed together. So a pine tree would technically be considered a mixture. Then we have orange juice. So think about orange juice. If you have a glass of orange juice, you're going to have the pulp, possibly. You're going to have water. You're going to have sugar or the fructose. So orange juice is also a mixture. Oxygen. Now oxygen has its own little spot on the periodic table, so it's an element. Iced tea. Iced tea, hopefully you said that was a mixture. If you think about a glass of iced tea, you're going to have, if you make tea like at home, when you brew it, you're going to have water in it. You're going to steep the tea in it, and you might even have a sweetener like maybe sucralose or even sugar in it. So it's a mixture of different compounds. Air. Air, this one's always kind of tricky. Air is actually a mixture. Let's just think about what a sample of air has. So let's say if I have this balloon, okay, that's not really a pretty balloon, but let's say we have a balloon, okay, and we have air in the balloon. So the air is going to have oxygen, obviously, because oxygen is in our air, but the greatest concentration of gas in the atmosphere is nitrogen. And there's some other various tiny minute amounts, but the air in the room is approximately 80% nitrogen and approximately 20% oxygen. So the fact that you have two different gases, or really more, because there are some other tiny amounts of gases, that makes it a mixture. Silver chloride. You got silver, you got chlorine. Look at your formula. There's two elements bonded together, so that's a compound. And then finally, H2O, water, made up of two hydrogens and one oxygen. Hopefully you said that was a compound. All right, so how'd you do on that? Hopefully, even if you missed one or more, hopefully you understand now. And if you don't, please make sure you ask me either by messaging me, or we can talk about it in class next time we meet. Okay, so on to today's lesson. That was a recap. Now we're getting into the new stuff. Let's focus on the elements on the periodic table. So what I'd like for you to do is I'd like for you to get your periodic table out. Remember, I'd asked you to print out a copy of your periodic table, but please get your periodic table out to refer to. If you need to pause the video, do that and then resume. Because I'm going to be talking a little bit about the elements and how they are arranged on the periodic table. So on the periodic table, the elements are arranged according to atomic number and their similar properties. Elements are arranged according to their increasing atomic number and their similar properties. Now, there's two ways that we can describe the organization of the elements on the periodic table. We could refer to the families or the groups. Families and groups are interchangeable names, but the families or the groups are the vertical columns on the periodic table. So they're the ones that go up and down, the tall columns. We call those families or groups. Now the families are numbered with Roman numeral 1A to 8A for the representative elements. Now the representative elements are the taller columns on the periodic table, 1A to 8A. Now the representative elements, these Roman numerals, tell us something very specific about the elements. And this is important for us to remember. We're learning about it today, but it's important for you to remember it throughout the rest of the course. The Roman numerals tell us the number of valence electrons in an atom. Now, hopefully you remember from previous science classes that if this represents your nucleus of your element, hopefully you remember drawing Bohr models. So let's just say if we have an element that has 2 energy levels around it, you would have 2 electrons in the first energy level. And let's say that you have 1, 2, 3, 4 electrons in the second energy level. Now, it could hold up to 8 in the second energy level, but let's just say we're stopped here with an element with 4. These electrons in the outer energy level are referred to as the valence electrons. They're the outermost electrons. So the fact that this little Bohr model that I've sketched has 4, 1, 2, 3, 4 valence electrons means that it would be found in family 4A, because the group number tells you how many valence electrons are in the element. Now that's for the representative elements. You also have the families that are referred to as the B elements or the transition metals. There's not really a pattern to what their numbers tell you, so we don't really learn a numbering pattern for those. Then we have periods. Periods are the horizontal rows on the periodic table. Periods run horizontally. On the periodic table, there are 7 numbered periods, numbered 1 to 7, and those numbers, the period numbers, indicates the number of energy levels around the nucleus of the atom. So let's just look up here at the Bohr model that I drew just a few minutes ago. Notice that I drew an atom that has 1, 2 energy levels around the nucleus. That means that this element would be located in the second period on the periodic table. So if you're counting down, it would be the second row across on the periodic table. All right, so a little terminology there and a little bit of tidbits of information about what those numbers mean to us, what they tell us. All right, now there's 3 classes of elements. The first class of elements on the periodic table are called metals. So let's talk about some characteristics of all metals. All metals are shiny, and if they happen to get kind of dull, you can polish them to a high shine. Notice here we have a sample of copper. Copper. Here you have shiny gold coins. Here you have a sample of gallium in this student's hands, and gallium happens to be a metal that is it is a solid at room temperature, but it melts very quickly. It does not take a lot of heat to melt it. So here you see he's got some gallium in his hand. All right. Malleable. Malleable is a characteristic of metals, which means they can be hammered into thin sheets. Think of a hammer. Another name for a hammer is a mallet, and that's where the word malleable comes from. Think of a mallet is a type of hammer. Malleable means you can hammer it or pound it into thin sheets, like this piece of copper metal here. Ductile or ductility is another characteristic of metals. Ductility refers to the ability to pull it or stretch it into a wire. Think about if you have electrical wiring in your home. All metals are malleable and ductile. Another very important characteristic of metals is their ability to conduct heat and electricity. Metals are conductors. They will conduct heat and electricity. And they have high tensile strength. And what that means is if you pull on it, it's not going to break easily. They're very strong. So these are the characteristics of your metals. And we will watch a short video at the end that talks about some of these just a little bit more, so to kind of drive the point home. One final thing about metals that I want y'all to remember, and that is mercury happens to be the only metal that is a liquid at room temperature. All other metals are solids at room temperature. If you think about all the metals you encounter on a day-to-day basis, whether it's copper, like in coins, or electrical wiring, or whether it's gold or silver or iron, they're all solids at room temperature, but mercury is a liquid at room temperature. Here are just a few examples of some metals and their uses. So here we have copper wire. Here we have the Gateway Arch in St. Louis. It happens to be covered in stainless steel, and stainless steel is actually composed, it's an alloy made up of iron and then two other metals, chromium and nickel. And so stainless steel is very strong, it's very shiny, it's very malleable, and has the ability to resist rusting. Aluminum foil is another. So we have so many different kinds of metals that we use on our day-to-day lives. The second characteristic, or the second class of elements, are nonmetals. Nonmetals have exactly the opposite characteristic of metals. They are brittle. They are poor conductors of heat and electricity. Some of them are gases, some of them are solids, and one of them is a liquid at room temperature, and that happens to be bromine. So you have most of them gases. So here we have a sample of chlorine gas, and you look at it and you see a little bit of color here, a little yellowish tinge. Then you have bromine liquid. You see the liquid in the bottom of this container here. There's your bromine. And then you have solid iodine crystals here. So the nonmetals are very brittle when they're in the solid state, which means if you were to try to hammer those, they would just crumble into tiny little pieces like this iodine is here. They're not going to hammer into a thin sheet. The third and final class of elements on the periodic table are known as the metalloids, and that's also known as the semi-metals. Metalloids are located exactly between the metals and the nonmetals on our periodic table. And tomorrow you're going to need your colored pencils, because we're going to do some color coding on our periodic tables tomorrow during our class time together. So metalloids are semi-metals. They have properties of both metals and nonmetals. So all of the metalloids are solids at room temperature under normal conditions, and we call that room temperature STP. Make sure you jot that down. STP stands for standard temperature and pressure. So metalloids, all of them are solids under normal conditions, standard temperature and pressure. Probably the most important characteristic to remember about the metalloids is they are semiconductors, which means they are used when you need something to conduct just a little bit. Where you find metalloids used, the most common place is going to be in computer circuitry, computer chips, calculators, where you need something to conduct, but not such a strong conductor.